Hey guys, welcome to question FM338 of the Further Maths Fortify study guide. So this question reads, the light overlaps in the shaded regions as seen in the bird's eye view figure above. The points at which the lights overlap coincide with the edges of the rectangular patch. Using this information, the total area of the shaded region in square meters is closest to what? And we have 5 options. Now, there's a couple of things that we're going to use in this question that we calculated in FM337. So if you're unsure of where I'm getting some of the numbers from, specifically the radius that we'll be using, that is covered in the previous video, so go back and have a look at that if you're not sure. So, what they're wanting us to find is the area that is covered off in this overlap. And a good way of breaking this down is if we were to look at just one of these lights, the breakdown would look like this. So we'd be looking for this area here. Because the lights overlap, we're looking for 2 segments, and they're the same size. So what we can use is our segment. So we're looking for the area of our segments, of these 2 segments, which means we can take the area of a segment and times it by 2, okay? So we're gonna create a little bit of our own formula, but it's really just using the segment formula and multiplying by 2. So we're gonna go 2 times, and now our segment formula, which is r squared times pi of theta over 360 minus half of sine theta. So, we have 2 variables we need to look at here, r and theta. Now in the last question we found that the radius of these lights, or of the light that's thrown by these lights, is going to be root 0.5 meters. So we're going to keep it in that exact form for now. Where things start to get a little bit more tricky is when we look at theta. And this is why. So if we get rid of some of this for a second. In order to figure out this question, we are going to create a segment that looks like this. So we're going to create a sector, and within that sector we have a segment that we're looking at, okay? So we need to be able to figure out what this angle is in here. And there's a pretty straightforward way for us to do that. What we've got here is a triangle that looks like this, and we're trying to figure out what theta is within our triangle. We know that these 2 lengths here are going to be the same as the radius, so we know that they're going to be 0.5 meters and 0.5 meters. The other really handy piece of information we have is that this box is actually 1 meter wide. We know that, we're given that in the diagram. It tells us that it's 0.5 then 0.5, so effectively 1 meter across. So we also know that this is going to be 1 meter here, which means that we can use our cosine rule to figure out what the angle is here. So our stock standard cosine rule for finding angles is cos of A is going to be equal to B squared plus C squared minus A squared all over 2BC. Rearranging this a little bit so that we will go straight to the angle without cos attached to it, we get a rearrangement that looks like this. So arc cos of B squared plus C squared minus A squared all over 2BC, like this. And now we're going to sub in our known values. So A we're going to replace with theta, because that's our angle that we're looking for. So theta is going to be equal to cos of -1 of 0.5 squared plus root 0.5 squared minus 1 squared all over 2 times root of 0.5 times root of 0.5. Plugging all of that into your calculator, you should get an answer for theta at 90 degrees. So this angle in here that we're working with is 90 degrees. We now know our radius and our angle, so we can apply it to this final formula. So our final area that we're looking at is going to be equal to 2 times root 0.5 squared times pi times 90 all over 360 minus 1 over 2 sine of 90 degrees. Plugging all of that into your calculator, you should get an answer rounded to 2 decimal places of 0.29 meters squared, which of course is closest to option C. If you guys have any questions about this question, please drop them in the comments below. Otherwise, I'll see you in the next video.